Today I will discuss about the quantity estimation of sewage. The sewage collected from the municipal area consists of wastewater generated from the residential area or commercial area or institutional area or from industry area. Now, the sewer network is also related to these areas. So, as a result, there are two types of sewage is there. One thing is sanitary sewage and another thing is storm sewage. So, sewage, there are two types of sewage. One is sanitary sewage and another is storm sewage. Now, first of all, to estimate the quantity of the sewage, we have to know about the sources of the sewage. So, first of all, we are interested in sources of sanitary sewage. The first one is domestic sewage. So, it comes from the domestic areas, that is from kitchen, toilets, washrooms, etc. Now, the second source is industry. Any industry is a main source of a sanitary sewage. The third is institutions. So schools, cinema theaters, hospitals, etc. These are the main sources of the sanitary sewage. And the last one is others. That means any type of buildings are not in this category. There are also some sewage extracted. So these are the main sources of the sanitary sewage. Now we have to evaluate the estimate of the sewage. So our next topic is estimation of the sewage. So first of all, write down this equation by which we can easily calculate the amount of sewage. So first, net quantity of sewage, that means the effective quantity of the sewage after addition or any subtraction or loss, etc. The first one is the quantity of sewage from any type of water works. This is the first and foremost source of the sewage. And after that, some private waters also added in this portion. So, plus some private water supply. This is also a small amount of sewage, but it increases the net quantity of the sewage. And the third thing is infiltration. This is also a additive factor. That means addition of infiltration. Infiltration means the amount of water from the rainfall. Now, these are the additive portions. So, from this portion, there will be some losses which we will have to consider to find out the net quantity of the sewage. So, now we will subtract the amount, the losses amount. So, first thing is water loss. The first thing is water loss, and the second thing is the water not entering into the sewerage system. There is also another loss, that is water not entering into the sewerage system. So, these are the 5 things. The first one is the quantity from the water works. Second thing is private water supply. The third thing is infiltration. These are the additive portions. And these are the subtractive portions, that is water loss and the water not entering into the sewerage system. This is before the sewage treatment. So, this is the main estimation of the sewage. Now, our next topic is the variation in sewage flow. So the variation in sewage flow is very much important to us to design a sewer, because the sewage flow varies from hour to hour, and it is also related to the water demand. So if we plot a graph like in this way, this is y-axis and this is x-axis. In y-axis we will put the quantity or discharge of sewage in liter per second, and in x-axis we will put in time, that is in hour. Okay, so in the graph we will show that this is 0 hour, that means at 12 am. Suppose this is 24 hour. That means it is a cycle of a 1 day. Okay. So if we think that this is at 8 am, that means in the morning, and this is 6 p.m. It means it is in the evening. So in the morning, as it is an office culture, so in the morning there will be a high amount of water demand. Suppose this is 8 a.m. and this is 6 p.m. This is the graph of water demand. That means in the morning at 8 a.m. and in the evening at 6 p.m. the water demand graph, if we see the water demand graph, there are two peaks at 8 a.m. and at 6 p.m. At 8 a.m. the peak is greater than the 6 p.m. peak, and this is water demand graph. This is water demand graph. Now, if we see the sewage demand graph, then it is also like in this way. At 8 a.m. the sewage is maximum, and at 6 p.m. the sewage discharge is maximum. But this peak is higher than this peak. This is the water demand graph. No? It is water demand line. And it is sewage discharge line. So this is actually the hourly variation graph in sewage flow, but it varies in different cities, different towns or different areas. It actually depends on the daily basis routine of the peoples of that township, and it also varies in different seasons. Like in winter, there will be smaller sewage discharge or water demand. In summer, it will be higher. Okay. So this is the actual variation in the sewage flow. Now in this topic there is also two types of relations is based on. The first one is maximum daily flow. That means in a day the maximum flow is 2 times annual average daily flow. Okay, this is an equation which we will have to remember. And the second thing is maximum hourly flow. Maximum hourly flow, that is also 1.5 times of maximum daily flow. 1.5 times of the maximum daily flow. Or if we put this value in this equation, then we will get 1.5 into 2 into annual average daily flow. That means 3 into annual average daily flow. So there are two equations which we will have to remember. Now in terms of velocity, there are also two equations. So please write down these two equations. first one is minimum daily flow. The first one is minimum daily flow, which is 2/3 of annual average daily flow. 2/3 of annual average daily flow. It is actually in terms of velocity in sewer. Okay, and the minimum hourly flow which is equal to half of the minimum daily flow. Okay, these two equations you have to remember. Now, our next topic is the estimation of storm sewer. Sewage. Estimation of storm sewage. So storm sewage, first of all we have to know storm sewage is related to the rainfall. That means runoff. So we have to know first of all the factors affecting the quantity of storm water. The first topic is factors affecting the quantity of storm water. It is the main thing which we will have to know to estimate the storm sewage. The first one is the area of the catchment. Second thing is size and shape of the catchment. The third thing is the slope of the catchment. The fourth thing is the obstruction of flow in the catchment. And the fifth thing is the intensity and the duration of the rainfall. These all are related to the storm shear. Please write down the factors affecting the quantity of the storm water. So, in the first thing is the area of the catchment. Suppose this is a catchment. If the area is greater, then the storm water needs some time to reach the sewer pipe. And the size and shape of the catchment. That means if the shape is like in this way. So if it is there is a rainfall, then it can easily go down into the downstream. But if this type of catchment, if rainfall is here, then it should take some time to go the upstream of the sewer. Similarly, slope, downfall slope and uphill slope, if there is some obstruction, then it will take more time. That means the time of concentration will be high. And the intensity and duration of rainfall is also very much important. If the rainfall intensity is very small, then there will be no storm sewer, almost no storm sewer, as there will be no runoff. Okay. So our next topic is the estimation of storm sewage. So there are two methods by which we can estimate the storm sewage. The first one is rational method. Okay, this is the first method, and the second method is empirical formula. Empirical formulae. So the first one is rational method. So in this method we have to know an equation, that is Q equals to CIA by 360. This is the equation where Q is the quantity of storm water in meter cube per second. That means amount of storm water in meter cube per second. C is the coefficient of runoff. C is coefficient of runoff. I is the intensity of rainfall. Intensity of rainfall. It is in, it has no unit, but intensity of rainfall is in millimeter per hour. And A is the total drainage area in hectare. So this is an equation by which we can calculate the quantity of the storm water. Now, if the drainage area is in kilometer square, then the formula will be CIA. If A is in kilometer square, then the formula will be Q equal to 0.278 into CIA. All the units are same, but the formula will be Q equal to 0.278 into CIA. The next one is empirical formula. Actually, there are so many formulae had already generated, and it depends on different types of site conditions. So there are not any particular formula by which we can calculate or estimate the storm water. So the main thing or the main formula is the rational method. So our next topic is the conveyance of sewage, which I will discuss in the next video. Thank you.